There. All right. Okay, so Juan said emergency locations. What else about job briefings is important? Janessa.
I noticed there's that little segment that's like, okay, here's any previous damage you noticed before we start working, in case like there is a miscommunication. There's like an assumption that we like accidentally damaged something.
Absolutely, yeah. The prior existing property damage. How many of you guys have uploaded photos? Yeah, that's good to have. And that stays with that job briefing forever. Okay, so let's say a year from now, the homeowner, because that's a rental property, comes on site and then remembers that a big truck, Darren was driving the grapple on it, and they want to point at us, and then now we're buying a new driveway. We can look back at the job briefings and be like, no, no, that's a lie. It was just like that when we arrived. So, liar. Yeah, that's good. Okay. What's that? If they are timestamped, yep, they're timestamped. It's all documented, so it's good. The submission date, time, and geolocations are on there, so it's good. I want to go more with what Juan was saying with safety. And what else do you guys think needs to be on that? Which can. Okay, perfect. An EAP is an emergency action plan, and that's important. So what is an EAP then? Okay, EAP. So the emergency action plan, identifying and assigning crew tasks on how they're going to facilitate in accomplishing a rescue or site-specific safety concerns on how we're going to mitigate those. That's the only thing that I'm concerned about this morning is those items. Okay, so we're gonna look over the job briefing, and again, this isn't to. I've seen it on all of you, so you're all guilty, most of you. Okay, so this is not to point out anything this specific person. This is just for information. Okay. So let's do. Why are you? I don't want it zipped. There we go. Okay, submission date March 7, 2023 at 2:20 p.m. Wait, what? This is not it. Wait, what? We are not. Oh, this is from California. These are the ones we used to do in Cali. There you go. We had to check all of these boxes, by the way. Tree species, the DBH, the height, distance to lines. Huh. Interesting. I don't know why it did that. All right. There it is. Okay, everybody see that? Perfect. Okay. So here's the front page, right? It's got all the information on it. Okay, so we got crew one, day of the week, okay, location, the time, emergency meeting location by truck 201. They're doing pruning. Work site was commercial, right? Aerial lift was being used. Everybody's got their PPE. Crew leaders are assigned with tasks. Emergency safety equipment is in place. They did a fantastic job on that, by the way. It was out, and as you guys see in the pictures. All right, so this is kind of where I want to spend most of our time. Okay, so traffic and public exposures, roadway traffic, pedestrian access, public proximity. Okay, that was selected as far as a hazard. There was overhead conductors. The terrain was pretty minimal, so no terrain hazards here. Site interaction hazards. Okay, public access into work zone. Okay, so that was selected. All right. Siberian elm, green ash, hay locust, American linden. They were semi-mature, mature species. I'm pretty sure there wasn't 50, but he selected 50, or somebody selected 50 of them. He's being pretty rambunctious about it. Okay. The only hazards were dead. Okay. Risk exposure. Take for what it's worth. I tried. That one's kind of fun to look at. Okay. All right. So I want you guys to notice something. So here's Brian, and he signed. Huh. That kind of looks like Jacob's signature. Oh, Janessa, you signed just like Brian does. Uh-huh. That's an error. Well, okay. All right. So those the things I want to point out right there. Okay. So let's go to, I did a safety observations. Okay, so here's my field safety observation. So this is the form that I fill out that's on you guys on the app, right? So just, I put that on there because I want to be transparent with everybody. You guys can see when I come out and I'm going to be doing random checks, right, on everybody. This is the kind of stuff I look for. This is for education. Eventually, as we get bigger, and I've been stressing this, guys, it's going to happen. We work for the utilities. They will have inspectors that will come through and look at this stuff. You're probably used to them. Bartlett probably had safety guys that come out. They had safety guys come out, and then they would do critical observable action or violations or whatever. So they would come out, right? So big companies like Bartlett, they'd come out, their safety team would come out, and they would observe and document your guys' job sites trying to find stuff. Okay. If they find something, they would do corrective action, talk to the crews about it, even shut the crews down and do corrective training on that. Okay. So this is the reality of where our industry is going and is currently on other larger corporations. Save a Tree does it. The mom and pop company I own, Mowbray Tree Service, they did it. When we get to a certain size, it's something that's going to have to happen because of our insurance purposes. Okay. All right. So location, who's doing it? Okay, Brian and crew performing a City of Colorado Springs median tree prunes on small honey locusts at the corner of the alleyway and Monument Street. Okay. So warning signs, right? We don't carry any of them, so obviously it's unacceptable. The cone setup is unacceptable. Okay. Vehicle position was good. The wheel chocks were non-existent. That's supposed to be unacceptable because he did not place wheel chocks out. Okay. So if any unacceptable position were found, please explain why. Oncoming traffic zone is set up really well, but they neglected to cone off the alley or entrance and exit point. Okay. So I wonder if I can open this. There we go. Well, that's a crappy grainy picture. Okay. But so here's the work zone. The cone setup on this side, and I love he is awesome. Okay. So he faced oncoming traffic. And I love that because we're protecting the guys from chipping, right? But we kind of neglected a really crucial point where you guys are actually chipping. So if you can see, again, I'll scroll down. We have an alleyway right here. All right. So Pedestrian and vehicle access into the work zone was selected. You guys did identify that hazard. You did the best that you could to mitigate that, and I think we are limited with cones. We could have spaced that out, moved the truck forward, or did something maybe a little bit different. But that alleyway is to be considered as a cone zone. Okay. Um, so as you can see, right, so Yoshida's there. He's got his pile of brush. When they began to chip, right, even if I wanted to chip where I'm supposed to on the sidewalk side, in this case it would be the driver's side, I don't want oncoming traffic to get sideswiped some of that, right? But my back is right there being exposed to that alleyway. And there was a couple times the cars kind of did come in and out. The area wasn't a high traffic one, but you can see that there's the church, there's a business there, and cars parked and stuff. It's a pretty active zone because it's paved. Okay, so just real quick, guys, the purpose of the job briefing, right, is to identify the stuff and then come up as a plan as a group to mitigate them. Okay, and if you recognize stuff, so like Janessa, Yoshida, if you guys recognize these issues, you have the ability, okay, to stop work and to change them. Okay, 100%. And again, I'm not dinging these guys. This is education. All right, um, the little things, the little things, are what bite us in the butt sometimes. A majority of the time. Okay, I'm just going to do this real quick. I'm going to climb this tree real quick without tying in. Right, I'm going to just make a few cuts and then we're going to chip it. I don't want to set stuff up. That's when accidents actually happen majority of the time. Because let's look at it this way. Where's your mindset if you're going to go to a job and it's a massive removal and a crane's there and the grapple's there, the big chipper's there, right? There's a lot of people there. Are you set to do a good job briefing? Your mind's like, oh, I got to be on point. I got to make sure the crane's good. I got to make sure I got my gear. I got to dial in. My saw's sharp. All right, now you're going to go prune a crab apple. Which one are you more likely to be aware and ready and set in place? The crab apple? You're going to do a job briefing for the crab apple, or you're going to do a job briefing for the crane job? Right? You're more likely to, it's all of us. I'm guilty of it. I'm more likely to do a job briefing for the crane job because I'm hyper aware, I'm hypersensitive, and I'm looking for stuff because I got a lot going on, right? I just go to the mundane crab apple, not to, ding on me, and they're important. I'm gonna go do a crab apple prune. I'm not too concerned with safety, so I'm gonna neglect. Maybe I'm just gonna climb the crab apple, and which I almost did yesterday, and not even worry about a harness. I was just gonna keep my handsaw on me and just climb up a few feet, right, and just make a few cuts. And it's like, no, Kevin, like knock it off. Don't do that stuff. This is dumb, right? We have harnesses, we have safety gears for a purpose. I was walking around without my helmet on, right? I came up, I had my hat, and then I realized I was like, this is stupid. What am I doing? Like, go put your stupid hard hat on. I know we're pruning crab apples, but I should be wearing a hard hat because there's overhead hazards, or I might fall or something like that. Okay, so the job briefings are important, and the more times you do them, and I'm guilty, guys. I'll be the first to raise my hand. We were out of the storm job just the other day. Okay, twice I forgot to do a job briefing. Twice on a freaking storm job. I was just so gung ho and excited about storm work that I knew what to do. I did it. Luke and I talked about it. We went right to work. I didn't even do a job briefing. I didn't take the couple minutes to fill it out and submit that and talk about it. Right. So I'm guilty. I get it. So, maybe this is for me, but let's just take a step back, guys. Focus on that crane or on those job briefings. Okay. And if you select stuff, let's make sure that we are mitigating those hazards because it just takes once. It takes once for Yoshida to get clipped by a car trying to squeeze by him while he's trying to grab a pile of brush. Because people are stupid and people in a hurry because they have to poop really bad, so they can't wait for Yoshida to get out of the way. So they're going to run over the back of his ankle. Now he's got a broken foot. Okay? And a broken foot is not going to heal the same way. And he's going to be maimed for life now because of something like that. And I hate to gore it out, but that's the reality of this, right? Our bodies are what help us do our job. Without my hands, I can't climb trees or run chainsaws. Without my feet, I can't drag brush and access stuff. So it just takes one time, and usually it's the little stuff. Copy? Everybody cool with that? Cool. All right. So I do look at the job briefings. I do check that, please. If you are there, and I don't mind if you guys start them at the beginning. Some of the stuff's easy. The job address, maybe the location, stuff like that. That's fine. Do as much as you can on the way there. But when you get there, just take the few minutes, walk through as a group. Each of you sign it, not the person doing it, but everybody has to put their signature on there. Okay. Okay. So let's start doing that. I want to see different signatures from now on. No copy paste signatures. And I'll look into that if that's the case. Okay. All right. Okay, cool. All right, ropes, guys. Ropes are awesome. They're one of the main reasons we're able to do our job is because of ropes. So the question is, what are ropes? What are ropes? Wait, what? I'm on YouTube. All right. During. Oh, am I on YouTube? I'm on YouTube.
Junior's mustache, is it real? Is customizing your car insurance with Liberty Mutual and saving hundreds? Real? Yes, exactly.
Okay. All right. So while I go and grab some stuff, there's a lot of cool videos out there. This one, I think, does the better job of kind of how they manufacture a rope. Like, so you pick up a rope. I'm gonna grab some samples here, and you look at it, and they kind of all look the same, but there are key identifying factors on the rope, and they have their own applications, their own strength tests, their own limitations. So we're gonna start from how's the rope made, where does it come from? What they don't explain is this is from the fibers. Okay, so they are getting the yarn on the bobbins. Prior to that, just real quick, all they do is they just take the material, whether it's polyester, nylon, high molecular polyethylenes, that stuff is just spun together into yarn. So this is after they have taken the chemical ones, or if they're organic, like hemp, woven them together, manufactured them into their fibers that they are, into the bobbins themselves. And so this is how they're spun together in the different ways that they are, okay? So we have to build off of that, all right? Do we have any questions before we begin? No? Okay.
Samson, the strongest name in rope, has been designing and producing rope in the United States for over 150 years. He designed and produced rope. using an one to highest capacity pencil test beds designed specifically for synthetic fiber ropes. Testing of new products, existing parts, proof loading for critical components, or third-party verification are all carried out in-house. We also perform periodic residual strength tests to determine customized retirement schedules for our customers. But the heart of the fiber goes from raw material to finished rope and fabricated products. It all starts with the raw materials: polyester, olefin, nylon, as well as the newer high-performance fibers like Dyneema HMPE, Technora, Vectran, and PBO fibers all arrive spooled on packages, ready to be twisted and braided into yarns and strands, then braided into finished ropes. Before it is put into production, incoming fiber is tested to ensure it will perform as expected. This is the first of many quality controls the fiber will see in its journey through manufacturing. The fiber packages are placed on creels, racks arranged to assemble the proper amount of fiber for each yarn in the final product before it goes to the twister.
Okay, so from the beginning, right? So obviously they're not the ones that are manufacturing the specific type of yarn. So I look at it like the food industry. Okay? When we get beef or we get corn or that from farms, usually the USDA, right, they will do their random inspections. So they take samples of the beef, of the corn, run it through their testing machines, they're able to find and make sure that there aren't any defects, pathogens, it's all quality control. Okay? They do the same thing before they even spin those ropes together. And that's what that little strand test is to make sure that when they get the samples, that those pieces of yarn, okay, meet the breaking requirements specified by the manufacturer. If it is outside that scope, right, their rope is not going to perform as expected. Okay, so from the beginning, these little strands on the rope are individually tested, not all of them, but they take random samples to make sure they follow the compliance. Okay?
At the twister, the assembled fibers are twisted to a specific level and direction determined at the engineering stage. There are several types of twisters used to twist fiber into yarns.
Okay, so the fiber, okay, and rope science is really complex, really complex. You can take a 24 strand double braid, okay, from Yale, make it 12 or 13 millimeters, and take a 13 millimeter same double braid, nylon cover, polyester cord. So they're polyester cord, nylon, polyester cover, nylon cord. Okay, same diameter, same rope length, but they are going to perform differently. It starts to reveal the process. So when he's talking about the twist of the strands, okay, these strands, the little filaments that are in there, are twisted to a specific amount of twist per length per strength. Okay? The reason why they twist them, right, is that's where you get your elongation. Right? So some ropes will still 24 strand double braid, 24 strand double braid, 13 millimeter. They're going to have different elongation properties. It starts from the very beginning of the little fibers and how they twist them onto the bobbins, turn them into yarns. And it's all like the science. It's nuts. But even from the end, those twists are kind of necessary. Any questions?
And yarns into strands. The size of the yarn and the number of yarns per strand depends on the size of the final rope. The amount and the direction of the twist are part of the design of the rope. Braided ropes are constructed with an equal number of strands that are twisted in opposite directions. The result is perfectly balanced and torque-free rope. The rope will not twist or untwist when loaded.
That's important.
When twisting and stranding are complete, the strands are wound onto a bobbin, ready for the braiding process. At the braider, the bobbins are loaded onto carriers. For 12 strand ropes, 12 bobbins are required. For 8 strands, 8 are needed. Sampson's Ferndale, Washington plant produces braided ropes exclusively, both single and double braids. The braid is wrapped onto a capstan that moves the rope through the braider. The speed of the capstan determines the pitch of the braid. Double braided ropes, a braided core within a braided cover, are produced by feeding a cord that was braided previously through the die while the cover is braided over it. Coatings are applied at different stages of a rope's development to enhance performance characteristics. Coatings can increase abrasion resistance, provide protection from ultraviolet light, increase the coefficient of friction, enable color coding, promote longer service life, and even increase the rope's tensile strength. The ropes are flaked into bins, then wound onto reels, flaked into crates, or packaged for shipping. The plant in Lafayette, Louisiana, produces both twisted ropes and braided ropes. Lafayette's 12-strand braider is among the largest ever built, while the horizontal braider has take-up capabilities suited to the production of long, continuous lengths of large diameter ropes. Here at the splicing benches, expert master splicers finish fabricated products. Eyes are spliced into the ends, thimbles attached, and chafe gear or protective coatings are applied before they're ready to ship. Lifting slings and grommets are spliced to exacting standards for length and strength. The end result is a product that can be relied upon to perform the most critical tasks safely and efficiently, time after time. Sampson, the strongest name in rope.
Cool. Cool. So each rope.
Watch what magnesium does to your bowel.
Why does Grandma's tummy look pregnant?
Look at that thing.
Dishwasher.
Look at that thing. I'm gonna get rid of that. Why is Grandma so ugly? All right. So rope from beginning, when we get to the yarn string, they are quality control, maintained throughout. I grab today a Samson rope reed, Yale, Pelican. I grab their ropes. It needs to perform the same way from the day I buy it to every year when I buy the same rope. Specification is brand new. Maintained. One thing he did mention, and let's put this in your little back pocket, is ISO 9000. You guys want to mention that? Some of you guys should know, we talked about it last year. We did hardware. Rating rope required. It's close. Part of it, yeah. Remember ISO 9000. So ISO 9000 is close. It's a separate organization. If you are ISO 9000, so ETSO, B&M, Samson, Yale, a lot of fall protection manufacturers are going to be ISO 9000 certified. So ISO 9000 certified. If you get that certification, that means you've gone through rigorous testing processes to be able to get that stamp quality. That means a third party has come in, not your own testing. If you're a manufacturer, right, you're going to test your own product to make sure that the splice is holding, the real performance you want to be, right? Has the strength that the rope says. Okay? Well, people like to lie. People like to fluff stuff up, right? So you get manufacturers say that they're doing the rope breaks at 5,000 pounds, but when actually when you put them on the test bed, they break at 4,200. That's close enough, right? 800 pounds, about 4,000. That quality control is important. ISO 9000, you see a company that has it, you can trust their products 100%. Everything that's on that product has been tested to whatever the standard is. So for us in our industry, right, the standard for ropes can be found where? If I want to use a rope, where can I find if I'm allowed to use a rope? Hey, be quiet. We've been answering ropes. Come on, Eric. You guys have been taking the test. You should know. Anzi. Oh, Anzi. Anzi Z133. In section 8. Okay. You can find the standards for work that you can use in all of those activities. Okay? So, one. What is one of the standards that our rope has to conform to when we work? Breaking diameter required. Remember? You know? Got you right? You know? No. What is it? What is it? What is the working load? What is the working load that is defined? Anybody know? Maybe? 5,000. 5,000. It's close. It's close. Anybody else know? 10? Now, 5,040. It's a little more than hardware. So, remember, is 5,000 for hardware, 5,400 for textile. All right, so ISO 1000, super important to recognize that. Usually a little black and white label that's going to be below it. Next week I'll have some of those stamps, like UL stamps, EN 1895, 1865, whatever it is, those stamps. Yes. It's international. Yes, it's international. So products like Petzl, ENM, PPL is in sanctions here. It's not the same. It's a verified third party testing. Correct. Yeah. So it is international. It's the world. So you can go from China, Japan, Australia, Canada. If you find an ISO 9000 certified company or product, okay, you can trust that the standards are the same across the board. Now, different countries have different standards. The UK, the European standards, they are way stricter than the US. They've got different standards. Now, in the UK, you can operate a carabiner at 22 kilograms. Right? 22 kilograms is under the 5,000 pounds. In the US, we like big heavy things, and then fatties, they don't like to. You can use 22 kilograms, but within the zone, the region, of more of the countries, there's going to be different governing on safety requirements. But the testing is the same across the board for ISO. Okay. All right. So we talked about the strands construction. So as those bobbins, right, they're twisted and they're braided. They are held at, I wish you could into it. So if you guys see that big capstan, the rope, the big purple and blue rope whips around a few times, and a couple big wheels, remember that? So that is controlling not only the diameter, but also how that rope lays on it. Right? So if it's a loose braid, it's a tight braid, right? It's knotability. That's what that unit does. So it controls the positive tension the entire time through the rope manufacturing the braid process. So even into that will dictate the performance and overall diameter. Right? All right. So basic rope passes around from in the back. It is a 3-strand rope. Okay, so 3-strand tells you what? How many strands does it have? 4. All right. 4. 17. 6, 7. Oh. Three strands, okay? So usually with 24 strand, we probably have how many? 48. 642. 24 strands. Okay, so that dictates the strand count. Now when you get into there's a difference between, this is a test question on the UDP, by the way. You get into the difference between a strand, okay, is going to be 3 strands, but they are spun together. Okay, usually one direction. Opposite, I don't know, but they're spun together, and the strands are spun together. All of those ropes, and this is important, guys. All of those strands are spun and twisted to the same direction. Okay? If you look at the other rope, the 16 strand, right? We have different layers. Right? You're going to be crossing between. You're going to have some 2 strands per area, 3, 4. Right? This one's a single strand between the layers. Okay? So why not just make them all kind of like the 3 strand? Why is there a difference between these? He mentioned it in the beginning. But why not just make, why the different grades? Why are we grading them together? It's a little more complex than just, let's just spin them together. Right? Perfect. Okay, stretch a bill, that's it, that's a good guess. Okay. Yep, yep, yes, yes. Okay. So if I have a nylon 3-string, and it's 13 millimeters in diameter, I have a nylon double braid, 13 millimeters. One stronger than the other, one differently. Now I'm asking, what do you think performance is? I use perfect. That's the issue of balance. You mentioned that the weaving creates balance. So who's worked with 3 strands? Okay? Yes, definitely you. Right? Was 3 strand invented back then? Oh yeah. Okay. So you worked with 3 strands. So when the 3 strand, we'll go over some really good things why it's people use. But the main thing is when it's under load, what do you think that 3 strand wants to do? Unwind. It wants to untwist. Okay? The 3 strand is going to be an unbalanced rope. Okay? What that means is that when I load it, it's going to want to equalize and unload itself. So you're going to get your load is going to start spinning. Okay? So the second you put a load on a 3 strand, it's going to want to unwind come undone. And so the hardware the load that's attached to it is going to start having dynamic movement. Okay? Now if we take a 16 strand or a 24 strand or 32 strand braided rope, okay, that rope is balanced. Okay? So now the fibers, and this is key when we get into kermit, okay, as well as the class 2. Okay? Right, so now we have, so instead parallel fibers right being pushed around each other. Now they're crossed. Now when it's loaded, okay, those fibers are going to share that load in equal sides. We're going to untwist together, which will give a balanced load. So that's why our 24 strand ropes that we use, when we drop a log on it or we're sitting on it, right? Unless there's a lot of hot in it, normally we just stay put. We don't start doing this. Okay, because if you were to climb on a 3 strand rope, even though it'd be rated for it, the second I start putting my load onto it, this is what's going to happen. It's going to be really hard to put a tree if I'm doing this the whole time, right? Okay, so that's 3 strand. There's some other key characteristics behind it. So 3 strand, right? It's 3 strand. So we have a lot more nubbiness. Space and technical term at the moment, but as you know, is its nubbiness. Right? Now, if you compare that to the 12 and the 16 strand, like those nubs are not as prominent as 3 strand. What do you want to find out with the nubs?
Yeah, I was like that. Ah!
One push-up for every strand.
Oh, brutal. No, I'm becoming a leader. All right. Okay, so nubs, right, the lens. This is what I'm talking about. Okay. So three strand has fantastic abrasion resistance. The surface area that's in contact with the tree branches and the trunks, the hardware is real minimal. It's just not a lot of surface. As opposed to a 16 strand, right? My nubs are little, so my abrasion resistance is going to be there. Okay? Now, that's key thing, right? You do a lot of crotching, you work with wood, you use a lot of, we're pretty abusive with ropes when it comes to people who use rope in the industry. We're the number one rope offender. We go through more rope than any industry crossing. Just the nature of the beast. We are hard on ropes. Okay? So applying the ropes and the characteristics to the application. So I have great abrasion resistance. Okay? It's going to last long, but I have an unbalanced rope. So that's going to give me performance issues when I have it as a load. So three strand is great. If it's cheap, way cheaper than 60 strand, 24 strand, and other ropes that we use. It's great for natural cross breeding. Pulling trees over is good, although sometimes you can get five to one up. But it's good for just light duty, just quick and dirty kind of rigid. Okay? Now, the what they're made. Okay? So three strand is usually made of nylon or polyester. So nylon is going to be stronger. I'm going to put it up the graph there. I have it up. The graphics for the degradation flow. But also knowing what is it made of is key into selecting the work that we do. Okay? So polyester, we're going to get more stretch, we're going to get more elongation, right? It's going to be soft, supple, easy to knot, user friendly. Nylon, on the other hand, is going to be more robust, it's going to be stiffer, a little more difficult to work with. So again, the manufacturing, what it's made of, is going to play key into where I place it. If it's something that's going to do a lot of knotting in, I'm going to go with polyester. There's a little strength difference between polyester and nylon. Nylon is a little stronger than polyester, but it's not by much. It's like 15%. I will find information with that. But for me, right, we use ropes and we use a lot of knots and all kinds of stuff. We don't want polyester rope because it's going to be user friendly. I'm going to see more abrasion when I have it up in the tree. It's going to wear a lot quicker than my nylon is going to because polyester is more supple and softer. But I'm going to trade, in my rope selection, I'm going to trade knotability and suppleness as opposed to longevity. Cool. Any questions on free strength? Okay. 16. We'll go 16. Okay. All right. So there's two different ways that they will make 16 strand. Like now we're not doing the fusion, which is wrong. It's actually not even the balance ropes. Okay. 16 strand is going to be 16 strands. We're a lot more flexibility, user friendly, as opposed to your three strand as far as knotability, suppleness, ability to flatten over load. Some 16 strands have a central core, some do not. Classically, I think But now we have a balanced rope. Okay? Not going to be as robust and abrasion resistant as blue strand is going to be. Okay? And most of your 16 strand, and that's what they make, with a nylon. Yeah, nylon. I'm gonna find out. Okay, don't quote me on this, but I think actually I have it back. Polyester is more robust as far as the breakability than nylon. Okay. Before I give you guys false information, because I think I got them mixed up. Okay, no, I was right. Okay, yeah, I was right. Okay, nylon is more abrasive than polyester. I think I've got the loading. Polyester is stronger than nylon. Nylon is not as strong, but has abrasion resistance. Polyester is stronger, but not as abrasion resistant as nylon. Okay, everybody got that? Nylon, abrasion resistant, stiffer, not as strong as polyester. Polyester is stronger, but not as abrasion resistant as nylon. Okay, that's important when we get into the. What?
My brain is trying to
Nylon. Polyester. Sorry, polyester. Yes, and that's why I'm going that. So polyester, okay, is more abrasion resistant than nylon. No. Nylon is more abrasion resistant than polyester. Polyester is stronger. Nylon is more resistant. Okay? That's key when we get into the double twist. Okay? Because we're going to have a core cover relation. We can still make nylon cores, correct? Yes. Why would you have a nylon core? Because it's stronger. Yes. It's all. That's why I thought I was right, but then I started saying yes.
That's why I was giving you that look.
Yeah, polyester nylon. I was right. I was right. Polyester is better abrasion resistant than nylon. But nylon is stronger. I knew I was right. I was saying, yeah, okay. Because when we get into double break, we're not trying to. The what they're made of is a key indicator of how that works. So we're talking about it. Your double braid climate lines are really like nylon cover because they have better abrasion resistance. Polyester cover. Polyester cover. Polyester, the soft stuff is going to be on the outside. On your double. Nylon is going to be made of nylon is stronger but not as abrasion resistant as your polyester. You all confused? Yeah, me too. Okay. Polyester is usually on the outside because it's tougher. Okay? As abrasion resistant. Nylon is stronger than the fiber, but not as abrasion resistant as polyester. Okay? And that's the key thing for probably 99% of our climate lines of realize we do that combination. Okay. So 16 strand is not nylon, it is polyester. They usually have a nylon core. Sometimes some 16 strands do not have a core. Okay. The core is not load bearing. Okay. And this is in the load bearing topic. maybe a class twos. There might be core dependent. Same with permit. The permit is going to be more core dependent than a double grade. That makes sense. Next week when we have time. But 16 strand and 3 strand, okay? All 3 strands of the 3 strand are going to share the load. Okay? 16 strands, even 4 strands. Okay? All 12 and 16 strands are going to share the load equally. Okay? That makes sense? All right. We'll get into more complex, but the big takeaway for today is polyester is on the outside, nylon is on the inside. Polyester is now abrasion resistant, more so than nylon. Nylon strong, no rubby. Polyester, rubby, no strong. Okay? And then balance. Remember the balance of ropes. Okay? They are twisted in a specific way to form the diameter and performance of the elevation of the rope. Next week. Okay, any questions before we wrap this up? There's Mike. Sorry about that, guys. Cool. Okay, so next week we're going to continue on with construction. We're going to talk more about the polyester nylon relation, the way that they weave the different ropes as far as like the cover and the core, and different types of rope. Because I want to get this section real quick. Okay. Okay, so these look the same. Obviously, diameter is different and different colors. But they both look like the different. In reality, this one is actually stronger than this one. Because this one is going to be a core dependent rope, class 2. It's going to have what they call HMP. What we call your stick, your fancy blue rope. No, Amsterdam. Yeah, so Amsterdam. So that blue rope that's on your guys' winch line is actually stronger than the 3/4 ring because of its molecular properties. So a question I'm going to have you guys hang on to is why not just use that in ring application? Okay? We'll answer that. You should know because we've already been through this. Okay? Okay, any questions so far? So 3 strand, 16 strand, how ropes are made, applications, raising resistance. Understand? Previously question, but it's like a 16 strand with a cord. It still is just 16 strand. Yeah, so the only purpose, good question, thank you. So the only purpose of the cord in that 16 strand, which I'll pull stuff apart. I'll have better. I'm a visual learner, so I'm sure much better. I will have stuff next week. The core is just for its application. So do we want it to be supple, right, and not ability, or do I want it to maintain shape for hardware or reduce the roundness that happens when you go for a loading device? It's just performance based, not for the. Change the load there. I brought it up here. Okay, so they're both double braid. They look the same minus the diameter on the outside. The inside is what the big difference is. So on the inside, is the warm, gooey center. So if we pull this out, anyway, if we pull this out, you're going to see another rope basically on the inside. It has the cover and the core. On and steel, something with higher strength. The cover is just going to be for abrasion and UV resistance. So they look the same on the outside, but what it's made of on the inside is different. So not all fibers are. They're with the hand steel, that 3/8 inch hand steel you guys have, I believe is rated at 18,000 pounds. And that's 3/8 inches small. Actually, I think it's more. So what they did is they put that inside that rope. Right? The reason why they don't want it on the outside is one expensive. Two is they have high UV degradation. So those HMPE fibers degrade quickly under UV. They start to crystallize and lose their strength rapidly. And then they're not as abrasion resistant as the cheap polyester. So they'll cover, or manufacture the cover out of polyester, but the core is going to be the strength property. Does that make sense? Okay.
So it's just the performance that makes it strong, not the load.
What it's made of. It's what, so this is polyester, right? The other rope that's in the middle of it, that's the outlet. The double braid. This core is going to be made of a different chemical properties than cover. In polyester, this is going to be the rope like Spectra, Spectran, Technora, and steel, going to be whatever different names. So this is super strong. This is not in relation to strong, but it's not strong. So for the pin is 100% load being taken by the core. The only purpose for the cover is for that crazy. Make sense? Okay. We'll get more into that later. But yeah, question for you guys, we're going to answer and think about why not just use the strong wood. Okay. All right, any other questions? Good questions. So there's going to be two. So class 2 is the specific class. So class 1 is going to be it's going to be what it's made of. So class 1 is going to be your double braid, which class 2 is still double braid. It depends on what's in the core dictates what it is. The only way to know is if you know the rope by its manufacturer and stamp on it, or you look at it and you can identify. Usually they're different colors, but usually by manufacturer. That's the only thing between the two. It's going to be that kind of stuff. You're still going to have a 13 millimeter 24 string, but it could be a class 1 or but knowing that rope and what it was having. Good question. All right. All right, go. All right. Put chairs away and.